Learning about the scientific method, and the first thing that I like to do in all of my lectures is place an overview of what we're going to talk about on the board, just so there's no surprises and you all know what the lesson plan is going to be for today. So I'm going to go ahead and put that up. So this is our overview. We're going to first talk about the importance of the scientific method and why I like to teach it and why I like to especially teach it in the beginning of the year. We're going to talk about the background of it, and then we're going to go straight into the process, and then we're going to do one example together just so we can kind of flesh out how it works, what you're supposed to use it for, and certain things like that. So first we're going to start with the importance. I feel that the scientific method is very important because it's how we make 99.99% of our discoveries. A couple of them are based on luck, but those people were just really lucky. So the scientific method is how we try to understand how the world works around us, and is often the correct way for us to go about supporting a belief that we have in the world. And to start doing some background, the one person that we're going to talk about in this lecture pertaining to the scientific method is Roger Bacon. He was born in 1214 and he died in 1294. And he was an English thinker and experimenter, which is where he got a lot of his background in science. So, this guy is important because he is often considered or talked about as the father of the modern scientific method. There was lots of different ways of talking about the world and talking about how the world worked, but this guy kind of solidified that into more of a method around how to actually discover things in the world, and it was one of the first ones that was starting to begin being widely accepted. So his important discovery was that most of science had an underlying realm of mathematics. To understand science, you had to understand math, and that was his big contribution to the scientific method. So then, for just coming back out into a broader perspective, the way that we think about the process of the scientific method now was crystallized no later than the 17th, 18th century, and that's the process that I'm going to head into next. Okay. So, first we're going to go into the overall process, or you could say the highlights of the scientific method. First, you have to start with a hypothesis. And this is probably a term we've heard before, and I will expand it in a little bit after we go through the process. And then you have to have predictions. And lastly, you have to test those predictions. So we're going to expand this because there's actually a step-by-step process that you go through when you do the scientific method. So first, before you can even come up with a hypothesis, you gotta have a question. You gotta kind of know what you want to discover about the world. So our first step is to formulate a question. So then, after you think of the question, you can come up with a hypothesis. A hypothesis is described as something that moves to explain the observed behavior. It's what you think explains what you're observing out in the natural world. There's two other important things about a hypothesis. They have to be testable, meaning you have to be able to conduct some sort of experiment to show how you think your hypothesis works in the natural world. And leading after that, it has to be falsifiable. It has to be falsifiable, which means it has to be able to be proven wrong. You can't just pick a hypothesis that is right all the time. It has to be able to be proven wrong. After you create a hypothesis, you go to your prediction, which is letter B right up there. A prediction is what you think will happen when you're testing your hypothesis. It's the consequence of the hypothesis. So, after you form a prediction, you get to do what some consider to be the really fun part of the scientific method. You get to experiment. You get to create a study that you think will show or support your hypothesis. So for experiments, one thing that's important is you need to be able to have a control. You have to be able to compare what you're changing to a control. Because if you think about it, if in the entire experiment you have all these different, let's say people taking a certain medication, if they all get the medication, you're not going to really be able to compare it to what would happen if you didn't take the medication. So what you do is you would create two groups of people. You would create a group of people that took the medication and maybe a group of people that thought they were taking the medication but weren't actually. So you could compare the effect of the medication on those people. And then after the experiment, we have analysis and reflection. So analysis is when you analyze the data you got out of your experiment, when you try and figure out what your experiment told you about your hypothesis. And reflection is whether or not your experiment supported your hypothesis. Now the reason I use supported is very specific. You can never prove a hypothesis. You can never prove something to be true. You can only support it. And you support something by doing multiple experiments on it, by different people reproducing the same experiment, and the more data that shows in favor of that hypothesis is more support for that hypothesis. Or, if it doesn't support your hypothesis, you can go back and look at the beginning. It question and conduct a whole new scientific method. So that was a lot of information for you guys. So I'm gonna give you like a 20-second break while I erase this part of the board to kind of let that sink in.